Hi, this is Unit 4, Lesson 4, and what we're going to do today is match equations with their corresponding graphs. I'm going to probably do this in two parts because there's actually two different strategies. So what I had actually had my class doing was this math lab, and it was about Bruce and Monica and Sari, and they participated in a 5-kilometer walk for charity, and each of them had different plans to raise money from her or his sponsors. So these graphs showed how much or the amount of money a sponsor owes in related to the distance that they walked. So this is a linear relation. It relates two different sets of data. In this case, distance walked and the amount of money. Now notice that the distance walked is actually on the horizontal axis and the money is on the vertical axis because, again, let's review. The dependent variable always goes on the vertical axis. The amount of money depended on how far they walked. So what my students did was they tried different techniques in order to which equations m is equal to 2d plus 3, m is equal to 4d, m is equal to d plus 5, which of these equations match these graphs. So I just want you to pause this video, try it, and then come back. Welcome back. So we actually have here three different equations, 4d, m is equal to d plus 5, and m is equal to 2d plus 3. So some of my students actually created a table of values chart. Whoops. They went D, not M, X and Y. It's D and M because of our axes. And they said, okay, well, let's put 0 in for D. Well, let's see. If I put in 0 for D with this equation, I'm going to get 2 times 0 plus 3 is 3. So what they actually did was, well, they know that that's not Sari. That's definitely not Sari. Okay. It actually has to be Monica because that's the only point that is 0, 3. Okay, well, let's try 0 in for the other equations. So let's try 0 in for this equation right here. M is equal to 4d. Well, if I put 0 in for d, that's 0 times 4. So I'm going to get an m value of 0 as well. So that actually has to be Sari. So just process of elimination. This must be Bruce. But let's just make sure. Oh dear. There we go. Okay, so if I put in 0 here, I'm going to get 0 plus 5, and that makes sense. Okay, so that's a really good strategy, is actually putting in values for your variables and see which ones correspond on your graph. So that's actually our first strategy. So if you use the equation to determine the coordinates of 3 points, then match the 3 points that passes through those 3 points, or the lines that passes through those 3 points, then you actually will be able to match the equation with the line. Now my question to you is, why would you pick 3 points? Like, why not only 2? It only really takes 2 points to draw a line, but why would you choose 3? Well, I know I'm not perfect, and I know that sometimes I make a math mistake, like a calculation mistake. So I always instruct my students to take 3 points and then match the 3 points to the line. Just in case, I don't want anyone making mistakes on this. So you can choose 1, you can choose 2, you can choose, I would prefer my students to do 3. So when I do my examples, I'm going to always use 3 points. So in my class example, it says, which equation describes the graph below? Justify your answers. Okay, so I'm going to choose 3 points. Notice that these are all in that slope-intercept form. Y is equal to, y is equal to, y is equal to, y is equal to. That's called slope-intercept form, and that's just a review from, I think, lesson 3. So what I'm going to do is I'm going to take my first equation, and I'm going to create my table. Now you remember, a lot of my students have difficulty remembering this. You can choose any values of x that you want. I'm going to stay around the origin here. I'm going to choose 0, 1, and 2 for my x. You can choose the negatives. I know I don't like doing calculations with negative values, so I'm going to choose my values of x as 0, 1, and 2. And I'm going to create a table. So when x is equal to 0, I'm going to have 2 times 0 plus 1, which is 1. When x is equal to 1, maybe I should do the algebra here. I'm going to get 2 times 1 plus 1, and I'm going to get 3. 2 times 1 is 2, plus 1 is 3. And then I'm going to go y is equal to 2 times 2 plus 1 is equal to 5. So I just created my table. Well, 0, 1, I could have probably stopped right there because that point is not on the graph. 1, 3, and 2, 5. We can already see, oh, that scale, but okay. Did I do something wrong here? 0, 1. Oh, 1, 3. Okay, yeah, sorry. Ay. Is it Sunday morning? Okay, so 1, 3, and then 2, 5 would be up there. You can see clearly that that doesn't match. So let's start again. Let's do 2x plus 3. And let's see if my values for these are going to be the same. So I'm just going to erase these. That's a nice thing about working on the whiteboards. So if you choose to use my whiteboards, go ahead. So 2 times 0 plus 3 is 2 times 0 is 0 plus 3 is 3. Okay, so I can already stop there. I know my math is right. I know that point's not on the line. I can stop. Okay, so I'm not going to choose this one. Well, let's try x minus 2. Let's try that one. Y is equal to x minus 2. Okay, so y is equal to 0 minus 2, and y is equal to negative 2. So when x is equal to 0, y is equal to negative 2, and that's down here. So again, I'm going to just choose one more just in case because of the, the similarity, just to make sure that I didn't do the math incorrectly. Y is equal to negative 1. Yeah, no, I know. I know when y is equal to 1, both of those points are not on this line, so therefore that equation doesn't match. Okay, so that means it has to be the last one. Oh, well, of course I had to put it as the last one. Well, let's just check. Okay. Okay, so we have negative x plus 2. Okay, so if I put in 0 here, I'm going to get negative 0, which doesn't make any sense because it's just 0. And I'm going to get plus 2. So when x is equal to 0, y is equal to plus 2. Oh, that's definitely on there. So we know we're good. So we have to try at least one more because there's infinitely many lines that go through that point. So let's try one more. So I'm going to get negative 1 plus 2. And I'm going to get plus 1. And so that's 1. So I have a point of 1, 1. So I have 1 and 1. That's awesome. And I have negative 2 plus 2, which will give me 0. So I know that this is my equation that matches this linear relation. Okay? Let's go on to the next example. So class example, match each equation with the graph below. So now I'm going to choose, I'm going to create my little table. And again, I'm going to choose around the origin. So I don't want to deal with the negatives. I like negatives. I just don't want to deal with them today. So I'm going to choose 1, 0, 1, and 2. So you have 3 times 0 plus 3 is 3. 3 times 1 is 3 plus 3 is 6. And 3 times 2 is 6, plus 3 is 9. I know I did this correctly. This goes up by 1s. This goes up by 3s. I know I have a constant rate of change. So now I just have to go graph these. So 0, 3, oh, that one's there. Okay. So 0, 3 is there. But 1, 6 is up here. So I know that's not my graph. Well, 0, 3 is up here. So that didn't work. So 0, 3, 1, 6, 2, 9. So graph C has the corresponding equation of y is equal to 3x plus 3. Okay. I'm going to go to this one because this one requires us to solve an equation. So I'm going to go to this one next. I like my y equal to form. I like that slope-intercept form, the y is equal to. Here I don't have y is equal to, I have x plus y is equal to. So this is in standard form or general form. So I have 0, 1, and 2. So 3 times 0 is 0, minus 3 is negative 3. 3 times 1 is 3, minus 3 is 0. And again, I'm doing this a lot in my head. If you need to, it's okay to show all of your work. So you get 3 minus 3, and that's where I got the 0 from. Okay? And then I'm going to do the 2. So 3 times 2 is 6, minus 3 is 3. And again, if you need to show all of your work, or if you can't do those two calculations in your head, which is okay, I get 6 minus 3, and that's where I get the 3 from. So now I have 0, negative 3. Okay, well, there we go. 0, negative 3, 1, 0, and 2, 3. Okay, I'm just going to erase that other point. So I know that graph B has a corresponding equation of y is equal to 3x minus 3. Okay, so let's just make sure that this graph, or sorry, my apologies, this equation matches that graph. It should, but let's just make sure. So I'm just going to erase this. Now this requires us to actually do a little bit of algebra. So let's go 0, 1, and 2. So I have when x is equal to 0, so when x is equal to 0, I take the x out, I put the 0 in. This one's rather easy because this is 0 plus a number is equal to 3. Well, that's just 3. Okay. Now, I'm just going to erase this just to save me some space. Now, what happens when x is equal to 1? Well, I have 1 plus some number is equal to 3. So I know it's equal to 2. But how did I solve it? Well, it's a plus 1, so I have to subtract 1. That's its additive inverse. What I do to one side, I have to do to the other. So I'm going to cancel that, and I get y is equal to 2. Okay? And then I'm just going to do the exact same thing. I know I can just erase this, and I'm going to put x in 2 in for x. I know that this says 2 plus some number is equal to 3. I know that number is equal to 1, but how did I get it? Well, I subtracted 2 from both sides. Positive 2, negative 2, they're additive inverses. And then 3 minus 2 is 1. So that's how I solve it. That's how I create my table. So now I have 0, 3. I have 1, 2. And really, that's all I need. The reason why we take the third is to make sure we did our math right. And I get 2, 1. Okay, so graph A corresponds to x plus y is equal to 3. Here's a class example. Now look at all these equations. They're all in standard form. So which of the following equations is shown in the graph? So I'm going to teach you something a little bit, I don't know, just to help you become a little bit more efficient in your time. If you look at this graph, you see this point and you see this point very, very clearly. Those 2 points are called your x and your y intercepts. Okay, so what you could do is when you create your table, you can find your x and y intercepts. Well, your x-intercept is when y is equal to 0. Okay, so any point along this line, your y is equal to 0 because you're not going up and down. Your your y-intercept is when x is equal to 0. So any point along this graph, your x is equal to 0. So you can actually choose those 2 points if you want. If you don't feel comfortable with that, you can go back and you can go 0, 1, and 2. It doesn't matter which 3 points you choose. I just see that the x and the y intercepts are very clearly labeled here. So I'm going to use that method. Okay, so I'm going to try, this one doesn't look quite right. These 3 don't look quite right. I'm going to choose this one first, just because it's the only one with the 8 in it. So let's substitute, well, what am I doing? Darn it. I'm going to take y is equal to 0. So where I see the y, I'm going to replace it with 0. You don't always have to substitute the x. You can also substitute the y. So x plus 0 is -8. So that means x has to be equal to -8. Well, that is one of my points. Let's try it and see if that's another point. So now I'm going to do x plus y is equal to -8. And now I'm saying that x is equal to 0. So I'm going to take x out and I'm going to put the 0 in. And I have y is equal to -8. And that's another point on my graph. So actually this is my graph, or my equation that matches this graph, just by using the x and the y intercepts. Just in case I did my math incorrectly, I'm going to choose one more point. Now I'm going to choose -4 and 4 because I can see that. That one's a really clear one. This one, well, that one's not too bad either, but it doesn't matter what point you choose. I just see because the -4 and the -4 is scaled, like it's on the scale, so I'm going to choose that one. So let's just make sure. Let's put that down. Let's put x is equal to -4 and see if I get y is equal to -4. Just to make sure I did my math right, always take 3 points. So x is equal to -4 plus y. How do I get rid of a -4? I use its additive inverse, which is +4. And those cancel, and you get y is equal to -4. And that is the point. So this has to be the graph. That has to be the equation that matches that graph. I just chose because I saw that my x and my y intercepts were -8, and that one to me made the most sense. I'm going to check that one first. Okay, let's try this one. Which of the following equations is shown in the graph? Well, now I look at my equations and I go, holy kaboly, none of them make sense. None of those, I have no clue. I have 4 here as my x-intercept. I have -2 as my y-intercepts. I have 2s and 4s and everything. So I'm going to go right and just to create the table. Now, I said always choose 0, 1, and 2. But what I'm going to do is I'm going to choose 0, 2, and 4. And the reason why I'm doing that is because 1 would have to be a fraction here. and I don't want to deal with fractions. I know 0 is -2. I know 2 is -1, and I know 4 is 0. I'm going to choose those as my x values. Okay? Now I'm just going to have to see which one is my y value. So I'm going to start with A because I have no clue which one to even choose first. So I'm just going to start with the first one. And believe me, I don't know what the answer is. Okay, so I'm going to just move that over. And I'm just going to erase these, okay, just so it gives me a little bit more room. Okay, so x minus 2y is equal to 4. So I'm going to say my x is equal to 0. 0 minus 2y is equal to 4. That doesn't mean anything. I can just erase it. So now I get -2y is equal to 4. I know to get rid of the -2y, I must divide by -2. And I get y is equal to -2. Okay, so when x is equal to 0, y is equal to -2. Well, that's on my graph. But again, infinitely many lines can go through that. Watch. Infinitely, that could be the line. So it doesn't matter, like any line can go through -2. So I have to make sure, like, see, this line goes through -2. So I can't just use one line or one point because a lot of lines would go through that one point. So I'm going to choose another one. I'm going to say that x minus 2 is equal to 4. And I say that x is equal to 2 now. So I'm going to take the x out. I'm going to put the 2 in. Now I have an equation. We've done these in the grade before. I have to get rid of my +2 first because I always do the order of operations in reverse when I'm solving equations. That's my additive inverse. Those two cancel, and I'm left with minus 2y. And this is equal to 4 minus 2, so I get 2 there. I have to divide by -2 now. So y is equal to -1. So when x is equal to 2, y is equal to -1. Wow, okay. Did I ever luck out? Let's see. I'm going to put that over here just so I can do my third point because I'm running out of room here. So x minus 2y, I'm going to do the 4. Just to make sure, I always do 3 lines. It has to equal to 0. So when x is equal to 4, additive inverse is -4. There we go. I can already see it. -2y is equal to 0. So that means y has to equal to 0. There's no other number. So this is the equation of this graph. I want you to pause. Now this one looks really ugly. I want you to pause this video and I want you to try this one. I know this one, there's a lot of negatives in there, but just do your table, try it, and then come back and then, you know, press play and see if you did this one correctly. So welcome back. The class example says, which graph does -2x minus y is equal to -12 represent? So here, I'm just going to move this, I'm just going to move this over just so I can do some algebra on the side here. Okay, so I have -2x minus y is equal to -12. Now, I know that I can't quite see the 0 one here. I can see the 0 one here. I can see the 5, and I can see, I can see a few which were good. I can see a few points that are good. Let's see what I see here. 0, I don't see the 0. Whoa, okay, I see the 2, the 5. So I'm just going to stay with 0, 1, and 2. And if they don't, those 3 points don't work, it's not a big deal. Okay, so let's go -2, 0, minus y is equal to -12. Okay, lots of negatives. So I'm going to go through this slowly. -2 times 0 is 0. So what I'm left with is -y is equal to -12. I don't want -y. I want positive y. So if you remember, the invisible number is 1. So this is actually saying -1 here. So, and that's your numerical coefficient. So really what I need to do is divide by -1. When I do that, a negative and a negative, when you divide the two negatives together, you're going to end up with your positive y, which is exactly what you want. And I get -12 divided by -1, which is positive 12. So when when x is equal to 0, y is equal to 12. Well, I see that. So I'm already starting to think that that's not the right graph. But let's try another point. Let's try 1. Is 1 a nice one? Okay, so 1 is a nice one on that graph. So let's try it. So -2x minus y is equal to -12. I'm saying now x is equal to 1. Don't get flustered with all the negatives. It's okay. So this is -2 minus y, -12, positive 2, got your additive inverse, -2, positive 2, additive inverses, -12 plus 2 is -10. Divide by that -1, because that's what the numerical coefficient in, even though it's invisible, it's still there. Whoops, positive y is equal to positive 10. Awesome. And that's exactly what I have. Okay, and I know that I'm not even close to this. I know my math is correct. If you choose to, you can go try one more. You should choose 3, so I'm just going to practice what I preach here. Let's do 2. I'll go through the algebra rather quickly. -4. Additive inverse. Do it to both sides. Because it's an equation, got to keep the balance. My invisible number there is 1. Got to divide it by -1. So I get y is equal to positive 8. So if I go over 2, I go up 8, and look at that. Beautiful. So this is the graph that matches this equation. Now, I found this website. There's 9 practice questions that matches the equations of linear relations to their graphs. I think it's a great little one to go to. And I guess we'll pause now and we'll go on to part 2.